Okay, when we're talking about food and energy consumption, we're not going to use watts or milliwatts, etc. But basically, they're all based on the same system. So you will have heard of the kilojoule when you talk about food. So as you'll see through this lesson, sort of a standard diet is about 8,700 kilojoules. And not surprisingly, kilojoules means 1,000 joules. Okay, so what on earth is a joule? Imagine you had 1 milliliter of water. How much energy would be needed to increase its temperature by 1 degree Celsius? So that's what 1 joule is. So you can see you wouldn't require much energy to increase its temperature by 1 degree. So that's why we generally deal with kilojoules, because joules by themselves are fairly small. Look, we don't tend to generally talk about megajoules. We will still just refer to everything in terms of kilojoules. Now, some older recipe or diet books will refer to calories, okay, which is an old imperial measure. And a calorie is just, look, it's roughly 4.2 kilojoules. So here in this book, they've used 4.184. Okay, so we'll start off with some conversions using joules there. We don't tend to generally convert between joules and kilojoules or megajoules and kilojoules. Okay, anyway, we're going from a joule to a kilojoule, so a joule to 1,000 joules. So the unit's getting bigger, the number has to get smaller. So we're going to divide to make the number smaller. Kilo means 1,000. And 300 divided by 1,000 is 0.3, and that's going to be kilojoules. Part B, we're converting megajoules to kilojoules, so mega to kilo means the unit's getting smaller, so the number has to get bigger. Mega means 1,000,000. Kilo means 1,000. How many lots of 1,000 in 1,000,000? Well, there are 1,000 of those. Multiplying them together, we'll get 14,000. And again, we've converted into kilojoules. Okay, now a more realistic conversion is converting between calories and kilojoules. And remember that 1 calorie is equal to 4.2 kilojoules. So in other words, a calorie is bigger than a kilojoule. So if we're going calories to kilojoules, the unit's getting smaller, so the number has to get bigger. So we're going to multiply, sorry, I've used the 4.2, but let's use the number they gave on the previous page, the 4.184. Okay, so we go to our calculator, multiply that together. Okay, so we've got 343.1 kilojoules. Okay, moving to part D, we're converting kilojoules to calories, so the unit's getting bigger, so the number has to get smaller. So we're going to go 1,600 divided by 4.184. Okay, so that's going to give us 382.4. This answer is going to be in calories. Okay, and in part E, we're converting from megajoules to calories. And look, the safest thing to do here, we're going to go from megajoules to kilojoules, and then from kilojoules to calories. Basically, we're making a metric conversion and then an imperial conversion, and it's very easy to get this wrong. Okay, so we've got 0.17 megajoules. Okay, now we're going to convert that into kilojoules, and again, just like we've got up here, you know, you've got a million joules and you're converting it to 1,000 joules, so again, it's a factor of 1,000. Again, the unit's getting smaller, so the number has to get bigger, so 0.17 times 1,000, so that's going to be equal to 170 kilojoules. Now we can convert kilojoules to calories. Again, a calorie is a bigger unit, so we need to divide by the 4.184. Again, just go to your calculator, so 170 divided by 4.184. Okay, so we've got 40.6, and that final answer is in calories. So 0.17 megajoules is the same as 40.6 calories. Okay, we're converting from kilojoules to joules. So kilojoules to joules, the unit's shrinking, so the the number needs to increase. Kilo means 1,000. And basically we've got 2.35 lots of 1,000 times another 1,000, so we've got 2.35 lots of a million. And that is going to be in joules. We're converting 54 megajoules into kilojoules. Again, mega meaning a million, kilo meaning 1,000. How many thousands in a million? Well, there's 1,000 of them. Again, megajoules to kilojoules, the unit's shrinking, so the number has to increase. So we go 54 times, and again divide those through to get 1,000. So we get 54,000. That's going to be in kilojoules. Converting calories to kilojoules. Again, a calorie is bigger than a kilojoule, so the number needs to increase. So 760 times that 4.184 number. Okay, so that's going to give us, rounded that off, 3,180 kilojoules. Okay, we're converting kilojoules to megajoules, so the unit's getting bigger, number has to get smaller. Again, these are the same things here. It's a factor of 1,000, so because the number needs to get smaller, we're going to divide by 1,000. Again, just move the decimal point 3 times to get 1.475. And again, the units, the final units will be in megajoules. We're converting kilojoules to calories, so the kilojoules are smaller, calories are bigger, so the number has to decrease. Again, going to our calculator. Okay, so we're going to get 59.8 calories. And the last one, again we're going megajoules to calories, so we're going to go from megajoules to kilojoules and then to calories. Okay, so from megajoules to kilojoules, we're going from a million to 1,000 joules. So if the unit's getting smaller, the number has to get bigger. So we're going to multiply by, and again it's that factor of 1,000 there. And then we're converting from kilojoules to calories, so the unit's getting bigger, so the number needs to get smaller. Okay, and again rounding that off, 215.1 calories we're in at the end. Okay, we've got an orange juice, or one glass, that's got 400 kilojoules of energy. If we want to know how many calories, again we're going kilojoules to calories, so the unit's getting bigger, so we need to make the number smaller. We're going to divide by the 4.184. Again, going to our calculator. And so we'll get 95.6 calories. Okay, we've got a box of 6 of those fruit and nut snack packs, and in total they can have a total of 14.6 grams of fat. Now each gram of fat is equal to 37 kilojoules, so we want to work out how many kilojoules of fat in the box. So we just simply take the number of grams of fat and multiply by the number of kilojoules per gram, so 14.6 times 37, and so we get 540.2. That's going to be the number of kilojoules of fat in the box, so there'll be other kilojoules in there. Okay, how many kilojoules of fat are in one of the snack packs? Well, this is the total for 6 of them, so we just simply take that answer and divide it by 6. Okay, so we get 90 kilojoules of fat. And again, that's, 90 kilojoules, 90 kilojoules coming from the fat in each pack. Okay, how many calories of fat? Okay, so we now need to convert from this kilojoules into calories. So calorie is a bigger unit, so the number needs to get smaller. Okay, so we get 21.5 calories just from the fat in each pack. Okay, so Annalise bought a lunch which consisted of the following items. So a 1/4 barbecue chicken, 2,120 kilojoules, a small fruit salad, and an iced chocolate milk. Part A, calculate the total energy for Annalise's lunch. So we're just going to add those numbers up. On our trusty calculator. Okay, so we're going to get 4,484 kilojoules. Okay, part B, what percentage, correct to one decimal place, of the recommended daily intake of 8,700 kilojoules does her lunch represent? So for an average person, this is how much energy they should consume each day, just to take account of everything they do. Now, it's only an average figure. Somebody who's much more active will go through a lot more energy than somebody who's more sedate, and it depends on the amount of how old you are, if you're pregnant or not. There can be a lot of other factors there. But in this particular case, all we're going to do is take that total there. We're going to divide it by the number of calories that she should consume in a day, multiply that by 100% to make it a percent. So we actually get 51.5%. So you can see that particular lunch, if you were to have that, that's over half of what you should eat for a whole day. That's why it's much easier to put on weight than it is to lose weight. Okay, so we've got a table here showing how much energy used by an 18-year-old male weighing 75 kilograms and with a height of 170. And so this is for each activity if they were to do it for 30 minutes. So if they were to do 30 minutes of weightlifting, they'd burn up 465 kilojoules, all the way through to running, 1,240 kilojoules for that half hour of an exercise. Okay, Part A, name the two activities that would best help Michael use this energy in physical activity and state how long he would need to do them if. Okay, so this is a bit of a complicated question. So the two activities that would quickest use up the energy are touch football and running. So let's write that up here. Okay, all good. Now, they'll burn up 1,240 kilojoules for each half hour of exercise. Look, probably the easiest thing to do here is to double that. Okay, so say that they're going to use up, so doubling that, we're going to get 2,480 kilojoules per hour. That's going to make our work a lot easier. So basically, if he consumes a bacon and egg roll there, so the amount of running or touch football he'll need to do will be this number divided by this number, and that's going to give you an answer in hours. So 2194 divided by 2480. Okay, so going to our calculator, so 2194 divided by 2480. Okay, so we get an answer of 0.88 hours. Now, I don't know how much that is, so I'm going to press the degrees, minutes, seconds button, and I find that's equal to 53 minutes. Okay, so that's part one just there. Let's come down and put our answers down a bit lower. So now we'll do a part two here. Okay, so this time we've got a chicken teriyaki salad. So we're just going to go that 1,055 kilojoules divided by the number of kilojoules burnt in 1 hour. Again, we're going to get an answer in as a decimal number of hours. So we're going to get 0.409, and that's the number of hours. Again, press degrees, minutes, seconds button, and to the nearest minute that will be 25 minutes. So what's happened there is your calculator has shown this. So you've got 0 hours, 24 minutes and 33.39 seconds. Because this is over 30 seconds, we need to increase this by 1 to get that value of 25 minutes. Okay, part B. Selena is an 18-year-old female, 170 centimetres tall, weighs 62 kilograms. Calculate how long it will take her to use the energy in a bacon and egg roll for each activity below, with the given energy used per 30 minutes. Do the same for the chicken teriyaki salad. Okay, so we don't need this sheet. Let's move that over there. Okay, so B, part 1. So again, what we're going to be doing here is we'll double this to work out the rate of calories per hour. So we're going to go the 2194, which is the number of kilojoules in the bacon and egg roll. We're going to divide it by 2 lots of 10.49. So again, that's just the number of kilojoules that would be burnt in a whole hour. And again, we'll just shove that into our calculator. Look, we get a decimal, but again, let's press the degrees, minutes, seconds button, and we'll get 1 hour and 3 minutes by the time we round that off. Okay, if she goes swimming instead, again, there's the same number of kilojoules in the bacon and egg roll. Again, we're going to divide it by 2 lots of that. And again, remember, we're doubling that to work out the number of kilojoules she'll burn in a whole hour. So again, we go to our calculator. Again, press the degrees, minutes, seconds button. 1 hour, 12 minutes. And that sort of makes sense that it'll take a bit longer to burn it because swimming isn't using quite as much energy as running. Okay, so bushwalking, again, the egg and bacon roll has as many calories. We double the half-hourly energy requirement. Again, press the degrees, minutes, seconds button to get 1 hour, 24 minutes by the time we round it. Okay, so now we're going to do the same thing for the chicken teriyaki salad. The only difference is all of these numbers here will change to 10, 15. I'm just going to write that out quickly. Okay, so very similar. So we've got the 1015 divided by 2, lots of 1049. Press degrees, minutes, seconds. We're going to get 29 minutes there to the nearest minute. Doing it with 918, we'll get 33 minutes. And doing it with the 787, we're going to get 39 minutes to the nearest minute. Let's just straighten that up a little bit.